So hey everyone, welcome again to my YouTube channel, and today we are going to solve a new question from our top interview 150 question series, and the question title is word pattern. So let's get this question done. So we have been given a pattern and a string, and we have to find if S follows the same pattern or not. Here follow means a full match such that there is a bijection between a letter in pattern and an empty word in S. Now here what it is given, that we have been given one pattern string and one string s, and we have to find that the string s follows the same pattern which has been followed by the pattern string or not. So let's understand this example and let's formulate some algorithm. So here I have taken the examples from our question, and using this example, what we are going to do is that we are going to first understand the question, that what is happening in these questions, and we are also going to formulate the algorithm using these examples. Now let's understand the examples first. So you can see that what we need to do actually in this question is that we need to find that the pattern which is followed by our first pattern string is being followed by our s string or not. In here you can see that we have pattern first A, then again we have 2B, and again we have A. This is a pattern. Now again when you see in our SS string, you can see that it has dog, it has two cat, and then again it has one dog. So it is same pattern as the previous one. So by this pattern, you can simply also say that here the A is mapped to dog and B is mapped to cat. That means whenever you have A, we have dog, and whenever you have B, we have cat. That means every character in our pattern is mapped to a unique string in our SS string, and by this you can simply get the same pattern. It is very clear to understand. Now in this second example, you can see that what is happening is that our first character can be mapped to a dog, and when again you get a character, you have to replace it with dog. And here you can see that B is correctly replaced with cat two times, but here at the last, in place of dog, we have face. That means we are again mapping our A with a wrong value, which is not correct. So to handle this, what we have to do, we have to formulate an algorithm, and we have to find out that this whenever this case arises, we have to return false. And whenever this case arises where all are matching, that means there is a mapping with a very correct sequence. That means our all pattern characters are mapped with all strings, and it is be unique. And in that case, we return true. And if it is not the case, then we have to return false. Now let's start thinking about the algorithm. In the first part of algorithm, what we can think of is that the first point which is important, that the pattern length and the string length should be equal. That means if you have pattern of length here 4, and so we must have the word equals to 4, because if we have any mismatch, then it is not going to follow the pattern. So this is the one condition which arises to us, and second condition which is that accessing these words is very difficult to us, and it is going to take a lot of time. So what we can simply do to solve this two problem, we can store this as a string in a vector. We can store all these unique strings in the vector, and we can access in the future by using v0, v1, v2. So this will be simple for us, and after that we can simply check the size easily. Now let's think about the approach which we can check if it is a pattern or not. So what we can do is that we can take two map. First is M and second is N. And why we are taking two map is the reason that we have to map a unique character with a unique string. That means a unique character must be mapped to a unique string, and a unique string must be mapped to a unique character. Because here you can clearly see an example too, that our B is mapped to a unique string, and our unique string cat is mapped to B, but here A is mapped to B, and also it is mapped to face. So this is going to be a cause of reason where we have to return false in this case. And to solve and to handle this case, we are taking two maps uh, which are going to satisfy that the mapping should be unique. Because if we have one map, then we cannot ensure that our mapping is unique or not. But when we have two map, we can simply check if both the map has the same value or not. By using two map, we can simply ensure that the map is unique, or mapping is unique, sorry. So this is the algorithm which we are going to follow. Now let's understand by coding that how we can code this algorithm. So let's start by taking a vector of type string, and we are going to store our s string. Let's take it as v. and we are going to run a for loop for int I equals to 0, I less than s dot length I plus plus. Now what we have to do is that we have to store the words present in our S string in our vector v. And to do so, what we can do is that we can check if our si is not equals to a space. So if it is not equals to a space, what we can do, we can store it in a string. So for that we can also declare a string. So we are going to declare a string st is equals to, let's take a empty string. Now, what we have to simply do is that we have to store that character in this string. So we can write st.pushback si. And until we do not find a space, we are going to do this. And when we find a space, what we have to do, first we have to insert this string in our vector. So we will do v.pushback our st. And next, for our next word, we have to empty our string also. So we will write st.erase. That will delete all the characters present in our string. Now, one thing which we again need to do is that it has stored all the characters till this space, and after this it is not going to get any space. So for that, what we can do, you can again do st dot pushback sorry v dot pushback st. So you have already we have already stored this character, that means the last character in our st. So after this for loop, we can simply do v dot pushback st. So what we have done is that we have stored all the words in our v vector. Now first what we can do, we can check if our pattern dot length, if our pattern length is not equals to our vector length, that means v dot size. So if it is not equal, we can simply return false. So we have handled the first condition. Now let's move on to the main, which is where we are going to check if it is a pattern or not. So for that, we are going to run a again for loop int I equals to 0, I less than, you can run this for loop in our pattern because the size is same, pattern dot length I plus plus. Now next what we have to do is that first we need to insert the character, and when we have to insert is that when we do not have any value in our map, and firstly we have to also declare our map. So we are going to declare unordered map, first of type char comma string, let's take m, and again unordered map, and this time it will be of type string comma char, let's take it as n. Now what we do is that we will first check. Now we are going to check is that if our we are able to find or not. So if we are not able to find, we will insert. So we will do m dot find, and which value we are finding. Firstly we are finding for the character, so it is going to be pattern I. So if we are, it is equals to m dot end, so it is an indication that we are not able to find. And again we are going to do for the our words. So in that we are going to do n dot find our v I is equals to n dot end. So in the case when we are not able to find this relation, so we are going to insert that relation. So we are going to do m pattern I is going to be equals to our vi. Now similarly we can do n vi. It will be the reverse for from the previous. It is going to do pattern I. So what we have done is that we have firstly mapped our character with our word, and secondly what we have done is that we have mapped our word with our character. Now next what we have to do in else part, that means this time we are able to find. So what we can do, we can check, And what we are going to check is that if our m pattern is equals to, that means it is not equals to, sorry. So if it is not equals to our bi, and again same for this one, that means the, if we are able to check that any one mapping is not present or it is incorrect, so in this case what we can simply do, we can simply return false. Return false. Now what we can do is that if all the loop passes correctly, simply we can return true. So now let's run this code. Okay, so this is accepted. Now let's submit this code. Okay, so this is successfully submitted. So this is the question for today. This is a very interesting and important question from our series of our map, in which we are generally using maps. So this is for the today. Thank you all.